Students, our next topic is Kirchoffs equation, that is the continuation of thermodynamics topic. This Kirchoffs equation gives the exact relation between the heat of a reaction, that is nothing but enthalpy, with temperature. That means how the relationship between enthalpy and temperature it is given by the Kirchoffs equation. So it can derived easily with the help of first law of thermodynamics. What is first law of thermodynamics means? The conservation of heat energy is nothing but first law of thermodynamics. With a mathematical equation we can say that Q is equal to W plus delta E. So that is our first law of thermodynamics. With the help of first law of thermodynamics we can easily derive the relationship between the enthalpy, that is nothing but heat of a reaction, and temperature. The total reaction is carried out at constant pressure. So imagine that the A is the reactant, it is converting into B, that is our products. So let the reaction A gives rise to B. This reaction is carried out at constant temperature. So the HA is nothing but heat content of the reactant, or we can say it is a enthalpy of the reactants A. Next, HB is nothing but heat content or enthalpy of the products. Okay, HA and HB. HA is nothing but enthalpy of reactants and HB is nothing but enthalpy of products. So what is the change in enthalpy? So change in enthalpy delta H is equal to HB minus HA, that is the product enthalpy minus reactant enthalpy. It gives the change in enthalpy, that is delta H. So if we differentiate the above equation with respect to temperature, so if you differentiate the above equation with respect to temperature and the condition is at constant pressure, so what is the reaction then? So differentiation is nothing but differentiation of delta H with respect to temperature. So delta H by dt, that is equal to differentiation of HB by differentiation with respect to temperature, and minus next differentiation of HA with respect to differentiation of temperature, and it is all at constant pressure. And we know that dH by dt is nothing but Cp. So heat capacity at constant pressure, Cp is nothing but heat capacity at constant pressure, that is equal to dH by dt. That means in the place of dH by dt, we can substitute Cp. Understand? So in the dH by dt place lo manam Cp ni rayachu. Next step is differentiation of delta H by dt is it is as it is. Next here we have two Cp terms here. It is also dH by dt. Idi dH by dt ne, idi dH by dt ne. So both are Cp only. But what is the difference? HB is nothing but it is belongs to products. So CPB minus HA means it is belongs to reactants. So CPA. CPB minus CPA, that is the heat capacity of products and molar heat capacity of reactants. Okay, CP and CPAB are the molar heat capacities of the products and reactants respectively at the given pressure. We can write, so ఇప్పుడు ఈ dt ఇటు బైలో ఉంది. If you cross multiply this, what we get here, CPB minus CPA is equal to delta Cp. So this is the difference between the molar heat capacities. We can write it as delta Cp. Next, so we have here d into delta H by dt, that is equal to delta Cp. This is nothing but change in molar heat capacities. So if you take this dt to this side, what will happen? What we get here, d delta H is equal to delta Cp into dt. This is called as Kirchoffs equation. This is one of the form of Kirchoffs equation. So if you integrate the above equation with respect to hydrogen, so with respect to enthalpy and temperature, if you integrate the above equation, so this is the integration terms, and lower limit H1 and upper limit H2. We have here enthalpy, that's why we are taking limits as enthalpy terms, and here integration with respect to temperature, that is lower limit is T1 and upper limit is T2. So we know that integration and differentiation will get cancelled. We have to multiply that. So if you have to substitute once higher limit, that is delta H2 minus lower limit, that is delta H1. In the same way here differentiation integration will get cancelled. Delta Cp we have to substitute upper limit, that is T2 and minus T1. The above equation can also be written as సో వాట్ విల్ హ్యాపెన్ T2 మైనస్ T1 మల్టిప్లికేషన్లో ఉంది, తీసుకొస్తే బై అవుతుంది. సో డెల్టా H2 మైనస్ డెల్టా H1 బై T2 మైనస్ T1 దట్ ఈస్ ఈక్వల్ టు డెల్టా Cp. ఇట్ ఈస్ కాల్డ్ యాజ్ Kirchoffs equation. So how can we define Kirchoffs equation? Means the change in the heat of a reaction. This is the change in the heat of a reaction, or we can say change in enthalpy of a reaction at constant pressure. This total equation we are taking at constant pressure, no? So the change in the heat of a reaction at constant pressure for every degree change of temperature. T2 minus T1 is nothing but change in temperature. We can also write it as delta T. So for every degree change of temperature is equal to the change in the heat capacity at constant pressure. Delta is nothing, it indicates the change. In which change? Cp is nothing but heat capacity. P indicates the constant pressure. So once I am repeating the total equation, I'm trying to define this. The change in the heat capacities of a reaction at constant pressure for every degree change of temperature is equal to the change in heat capacity at constant pressure is called as Kirchoffs equation. So if the same reaction is carried out at constant volume, what will happen? So constant volume, we know that delta H is equal to delta E plus P delta V. If delta V term becomes 0, what will happen? Delta H is equal to delta V. So the total equation can be converted with the help of a volume, that is delta H2 minus delta H1 by T2 minus T1, that is equal to delta Cv. So delta Cv is nothing but again same equation, the only difference is constant volume. So this gives us a Kirchoffs equation. So this is about Kirchoffs equation.